Okay, this is a quick video to explain Calc Day 23. There's two things: using nDeriv, which is called the numerical derivative, on your calculator, and also talking about where a derivative does not exist. So, these are the notes that you should have had from today, so hopefully you can have those to reference. First example says use nDer, that's short for nDeriv, the numerical derivative on the graphic calculator to find f prime of 1 if f of x equals x cubed. Okay, so at this point, the only way you know how to find an expression or an expression for f prime of x is to use that whole limit as h goes to 0, or the difference quotient, f of x plus h minus f of x all over h. And you could do that with 3x cubed and eventually plug in -1 and get what f prime of -1 would be. But the calculator can do that for you. So on your calculator, here you go. First step says go to y equals, put in the equation. So I want x cubed. So go to y equals, type in x cubed. There we go. Next up it says on the home screen, we want to go to math 8. So the home screen is when I get out of this screen. That's my home screen. Math 8. So math, if you go all the way down to 8, you'll see, I should say, nDeriv. And new calculators will look like this. So remember, that's derivative notation. So it's the derivative with respect to x, we want x there, of whatever function I put into y1. So the way I get y1 here, hopefully you've seen this before, you go to vars, V-A-R-S, over to y vars. You want function, so choice 1, and then y1, that's what's stored in y1. So we want the derivative of the function in y1, and I want it specifically at x equals -1. So I put -1 in here, and we get 3.000001, which is just a rounding error. The answer is really 3. Okay, so that's what it looks like on the new calc. The answer is 3. If you have an old calculator, let me change this to old calculator mode quick. If I go down to, switch over. First step still the same. I'm going to go y equals, put in x cubed. But then when I go math 8, we get a screen that looks like, oops, didn't mean to do that. That x cubed. When I go to my home screen and go to math 8, it says nDeriv now, and you have to know the order to type stuff in. The order is always the function. So in this case, the thing I stored in y1, then the variable, which is always going to be x, and then the actual x value that I want to evaluate, with commas in between. So if you have an old calculator, you just have to know to do that order. So I'm still going to do vars, y vars, function, y1, in respect to x, so comma x, comma the x value you want, which is 1 or -1? -1. And we still get that answer of 3. So this f prime of 1 is equal to 3. Remember, that means slope. So that's finding the slope of this function at x equals -1. I can also graph derivatives. We're going to be doing more with this by hand in a few days, but graph f of x equals x cubed and its derivative. So I could do that by going to, let's switch back to new calculator mode, because I think that's what most people have these days. So if I go back to y equals, got that x cubed in y1, I can actually go to math 8, get that nDeriv, put that right into y2 here. So I still want vars, y vars, function, y1 there. But instead of a specific x value to evaluate, if I want it for all x values, I just put x equals x there. And then when I go zoom standard, you're going to see the original parabola, or sorry, the original cubic, x cubed. And then the derivative is this parabola, right there. And if you'd rather just see one, if you don't want to see the original equation, you can go to that y equals list, turn off equals on x cubed. So go to the equal sign and hit enter, that turns it off. And now when I graph it, I'll just see a graph of the derivative. So that's a graph of the derivative function, whatever it may be. So that's what this is saying. So if I want to graph f of x and its derivative, original function in y1, nDeriv in y2. The key is, instead of putting a specific x value, we put all values of x. Okay, now part of your problem set asks for questions like this. Use nDeriv to find an equation for the tangent line of y equals 1 over x squared at x equals 2. So as soon as you see equation for the tangent line, you know this is your goal. Y minus y1 equals m times x minus x1. To use that, we need a point and we need a slope. They told us x equals 2. So that's the x coordinate of my point. Remember where this y coordinate comes from. It's the y coordinate on that original graph here. Because if I'm finding the equation of a tangent line, definitely the point on the graph is a point on that tangent line. So we plug in 2 into the equation that they gave me. So 1 over 2 squared is 1/4. So there's my point. Now to find my slope, I need f prime of 2. In the past, we've had to use definition of derivative, long process. Now I can just use nDeriv. So if I know I need the slope of 1 over x squared at x equals 2, I can just go to my calculator now. In y equals, here's my new equation. Let's clear out what's in here. So my equation is 1 divided by x squared. And on the home screen, if I want the slope specifically at x equals 2, I can go to Math 8. I want d over dx, the derivative of the function stored in y1 at x equals 2. Gives me my slope as, and what do you think that actually is? Again, remember the rounding error. So it's really like negative 0.25 or negative 1/4. So that's how I got that. So now I can get my equation of my line really simply. Just y minus 1/4 equals the slope negative 1/4 x minus 2. Okay, so that's using nDeriv on your calculator. The other thing I wanted to go through quickly was a question like this. Find f prime of 0 when f of x is the absolute value of x. Now, I'm actually not sure what nDeriv would tell us. Let's see. If I plug in absolute value of x, and then I did derivative at 0, so d over dx, that y bars function at x equals 0. I wonder what the calculator will tell us. Okay, now it says 0. That's not actually quite right, and you got to be careful with nDeriv because it doesn't always know when a derivative doesn't exist, and that's what's happening here. So remember what absolute value of x actually means. F of x is just regular old x if it's positive. So if x is greater than or equal to 0, nothing happens to it. But if it's a negative number, the absolute value unnegatives it, so it kind of negates the negative, so like a double negative. That's why it looks like negative x on this side. And that's what the equation of the graph looks like. Now, if I'm looking for the derivative at 0, the problem is there's a different equation with 0 from the left and 0 from the right. So the left-hand derivative, and this is using the difference quotient, is the limit as h goes to 0 from the left. Remember when I say difference quotient, what I'm actually doing here. So this is limit h goes to 0, f of x plus h minus f of x all over h, right? But if I'm coming from the left, I'm using this formula. So that's why there's a negative here. Negative x plus h minus f of x is negative x all over h. So this is really negative x. It's showing up here. I'm distributing the negative. So negative x minus h plus x. X's cancel. So I'm left with negative h over h. So the derivative from the left just reduces to negative 1. The right-hand derivative, if I'm coming in looking at the slope from the right-hand side, then I'm using this equation for f of x. So now f of x plus h is just x plus h minus f of x, which is just x, all over h. And you can see the derivative from the right is 1. But if the left-hand derivative limit doesn't equal the right-hand derivative limit, the limit as h goes to 0 does not exist. So any x value to the left of 0, the slope is negative 1. And that should make sense if you look at the graph. Remember, anytime you hear derivative, derivative means slope, right? So the slope of any point on this side is part of this line, which is negative 1. So the slope's -1 if x is less than 0. But the slope of any part of this line is +1. So the slope is +1 if x is greater than 0. At 0 is the problem. And since the left-hand limit at 0 doesn't equal the right-hand limit of 0, we say the slope at 0, f prime of 0, does not exist. So, for a derivative to exist at a point, the right-hand and left-hand derivatives have to be equal, just as any limits would have to be equal from the left and the right. So that's something you know, and it just is being applied to the derivative definition. So here's 4 times when a derivative does not exist. Obviously, if there's a discontinuity, there can't be a slope at a point that doesn't even exist. Like in this graph, there's no c value, there's no point at c, so there's no derivative there, there's no slope there. Second place is called a node, which is kind of more commonly referred to as a corner. And that's like the absolute value function. You saw y from the derivative from the left equaled -1, derivative from the right equaled +1. So left-hand derivative didn't equal the right-hand limit, so the limit did not exist, meaning the derivative did not exist. Cusps are similar to nodes, but they're curved. But the same idea happens. So the limit of the derivative from this side is not going to equal the limit of the derivative from that side, so the derivative does not exist. And the last place is a vertical tangent. So since, if you had an equation like this, since derivative is just slope, remember the slope of a vertical line is undefined. So if the slope is undefined, that means the derivative is undefined, so the derivative does not exist. So those are the 4 places on a graph where f prime, or the derivative, does not exist. Discontinuities, corners or nodes, cusps, which are like nodes, and any place where there's a vertical tangent line. And you can see that this would be a vertical tangent because as I picked points from either side, as I get closer and closer to that spot, I'm approaching a vertical line. That's why it's a vertical tangent. All right, so you should be able to do the next problem set. I believe it's problem set 22. So give that one a shot, and good luck.